Dear student, previous class we discussed discovery of electrons. In this session, we'll move for the next two fundamental particles, that are proton and neutrons. Okay, so discovery of proton and neutron is a side heading for this session. Okay, now in this discovery, just modify the CRT. What is the CRT? Cathode ray discharge tube. There, what that negative end to positive end stream of particles will move, but here which is reverse, fluorescent material which is placed behind the cathodes or negatively charged electrode ಯಾವುದಿದೆ ಅದರ ಹಿಂದ್ಗಡೆ fluorescent material ನ ಇಡ್ತಾರೆ. Then they observe one thing, what is that? So that is start from the anode to cathode end. Anode ends are what? Anode electrode are having the positively charged electrode. Okay, from that some particles are emitted or some particles are moved towards the cathode end, so that are positively charged species, and that ray particularly called as an canal rays. Hege ನೀವು cathode rays ಅಂತ ಕರಿತೀರಿ, positively charged species also having the name that is canal rays. Okay, so ಇಲ್ಲಿ experiment ಏನು ಬೇಕಾಗಿಲ್ಲ, just what modified the CRT tube, reverse to what? Cathode ray. Cathode ray ಏನು ಮಾಡಿದ್ರೆ ಅದರ reverse, that is canal rays. But here very important thing is what maybe asked for 2 mark question, write the characteristic features of what particular ray. So usually which is reverse to cathode rays. Okay, canal rays are which is reverse to cathode rays. Okay, just don't confuse with the name. Canal rays are positively charged, negative charge is the cathode rays. Okay, now I'll move for the characteristic features of the canal rays. The first feature is here, it depends on the nature of the gas. Okay, cathode rays, canal rays are depends on the nature of the particular gases. Yava gas na CRT ಅಲ್ಲಿ use ಮಾಡ್ತೀರಾ, that will depends the production of what? Canal rays. Okay, these are positively charged atoms, gaseous atom. I already told positively charged species are what? Canal rays. Canal rays na explain ಮಾಡಿ ಬರ್ದಿರುವಂತದ್ದು, explanation ಅಲ್ಲಿ ಕೊಟ್ಟಿರುವಂತದ್ದು positively charged gaseous ions. Okay, not only atoms, we can write the ions, because positively charged means what? It should be an ion. So that are canal rays. The first properties or first characteristic features of particular canal rays. Now we move for the second, charge to mass ratio. That also depends on the nature of the gas, where it is originated. So in the last class we have discussed the charge to mass ratio by J.J. Thomson and one more R.A. Millikan's. Okay, from that can obtain the mass of the particular electron. Here charge to mass ratio, you will find the mass of the proton and neutron also. Okay, mass of the proton and neutron also, that are depends on the what nature of the gas used again. Okay, next one more, it's very easy. Okay, behavior of the canal rays which is opposite to cathode rays. Cathode ray ಏನು behavior ಇದೆ which is opposite to cathode rays. Okay, canal rays ಅದಕ್ಕೆ ಅಪೋಸಿಟ್ ಆಗಿ ಯಾವ್ದಿರ್ತದೆ? cathode rays. This is about the characteristic features. You just remember one or two characteristic features. Okay, that may ask for the your board exams. Okay, write the characteristic features of what? Canal rays. Okay, now we'll move for the one more definition of the particular positively charged species. Okay, I already told in this what is that it will depends upon the nature of the gas. Okay, in case if you use hydrogen is a gas, H2 is a gas. If you use the hydrogen, it will produce the positively charged species, or if you use hydrogen atom, it will produce the positively charged species, and that species or negative positively charged species are having the lowest mass. Okay, lowest mass and smallest atom and the lightest positive atom. Lightest in the sense lower masses, very low masses, that are called as an protons. Okay, they may ask for one more question, what is the define proton? Proton is in the smallest and lightest positively positive ion obtained by the hydrogen. Hydrogen in the ಏನು obtain ಮಾಡಿರ್ತೀವಿ, that will produce the positively charged species, and that are known as an protons. Okay, protons we can write H plus now. Okay, so which is obtained by the hydrogen having the positive charge. Okay, these are very lightest particle. Okay, lightest particle H plus. Okay, then This is about what generally about the protons. Now we'll move for the neutron also, because atoms consist, any matter consists three fundamental basic units, okay, proton, neutron and electron. Neutrons also present with the protons, okay. Positively charged species ಏನಿದೆ ಅದರ ಜೊತೆಗೆ some electrically neutral, okay, ಏನಾದರೂ electric field, magnetic field apply ಮಾಡಿದ್ರೆ there is no deviations, okay, that are by the called as what? Neutrons, okay. Electrically neutral particles called as an neutron, okay. Both discovery done by the Chadwick, the scientist which is discovered by the discovered to what? Proton and neutron, Chadwick, okay. Now coming for the masses, okay, masses point ke bandre, coming to the masses, you should remember which is having the highest mass. Obviously electron having the lowest mass and proton and neutron present in a both nucleus, atom alli ಎರಡು ಇದೆ, orbit and nucleus. Nucleus ಅಲ್ಲಿ present ಇರೋದು proton and neutron. ಇದನ್ನ lower class ಅಲ್ಲಿ study ಮಾಡಿದೀರಾ. Out of protons and neutrons are having the slight greater mass, very small change, okay. For example, if proton having 1.672 into 10 power minus 27 kg, this is a one proton weight, and neutron will 1.6749 into 10 power minus 27 kg. Only this much difference, okay, much ಏನು ಇಲ್ಲ, ಕಡಿಮೆ ಡಿಫರೆನ್ಸ್ ಮಾತ್ರ ಇರುವಂಥದ್ದು, ಓಕೆ. ಹಾಗಾದ್ರೆ ಇನ್ ಜನರಲ್ ವಿ ಕ್ಯಾನ್ ಸೇ ನ್ಯೂಟ್ರಾನ್ಸ್ ಆರ್ ಹ್ಯಾವಿಂಗ್ ದಿ ಹೈಯೆಸ್ಟ್ ಮಾಸ್ ದ್ಯಾನ್ ದಿ proton. So just go through this box. This is very important for the ಪ್ರಾಬ್ಲಮ್ಸ್, ಓಕೆ. ಪ್ರಾಬ್ಲಮ್ಸ್ ಸಾಲ್ವ್ ಮಾಡಬೇಕಾದ್ರೆ ಕೆಲವೊಂದು ಪಾಯಿಂಟ್ಸ್ ನಿಮಗೆ ಗೊತ್ತಿರಬೇಕು, ಓಕೆ. ಯು ಶುಡ್ ನೋ ದಿ ಪ್ರಾಬ್ಲಮ್. ನಾವು electron, proton and neutron present in a matter which can symbolize by E, P and N. E refers to electron, P refers to proton and refers to neutron. Now coming for the masses, mass of the particular electron is 9.1 into 10 power 31 kg minus 31 kg. For proton and neutron, I already told 1.726 into 10 power 27 kg. For proton, 1.6749 into 10 power 27 kg for the neutron. Now in general, relative charges, the last column we can see the relative charges. The charges ಏನಿದೆ ಅಂತ, electron obviously negatively charged, we can take the -1, okay, and protons is +1, neutron is 0, okay, it's a 0. These are very important for the calculation purpose in the next concept, okay. Next we will move for the structure of the particular atom. The heading of the chapter is structure of atom. We will go for the different kinds of models to exhibit the or illustrate the structure of particular atom. Now continuation of the what? Atomic models. There are two types of models are there to describe the structure of the atom. In that first model, that's the J.J. Thomson atomic model. J.J. Thomson atomic model. Here just assumptions ಹೀಗೆ ಇರಬಹುದು ಅಂತ ಕೆಲವೊಂದು assumption ನ ಹೇಳಿದ್ದಾನೆ, and that assumption are discussed now, okay. Now in 1898 J.J. Thomson assumed that, okay, atom is in spherical in shape, it should be in a circular shape. Atom should be in a circular shape, and these are radius having the range of 10 power minus 10. Radius should be 10 power minus 10 meter, or in terms of Armstrong we can say 10 Armstrong, okay. 10 Armstrong should be the radius. Radius in the sense what? Distance between the center to circumference. This is in radius. This range should be the 10 power minus 10 meter. That means what? It should be a very smaller in that, okay. So there's a first point regarding the J.J. Thomson, where the spherical shape and the radius should be the very small. Next, positively charged species are uniformly distributed. So just imagine this is a J.J. Thomson atomic model. In that the red lines are, or these regions are what? Positively charged species are located, which will be the uniformly distributed. In this region, positively charged species are uniformly distributed, and this circle indicates the electron. Now this should be the electron, and here proton should be present. Proton and electron present in this, okay. So these regions, what the red line regions are positively charged species uniformly distributed, and which is embedded by the electrons. Electrons are circular portions present in this atomic structure. This entire model they consider as an atom. The entire model na atom anta consider ಮಾಡಿದ್ದಾರೆ. So in between that circle, that is a positively charged species, that circles are what? Electrons. Okay, and electrons are embedded in it. Okay, ಇದರ ಒಳಗಡೆ ಏನಿದೆ? Electron present ಇದೆ. Most stable electrostatic force. There should be an electrostatic force between the proton and electron. Okay, ಇಲ್ಲಿ ಇವೆರಡರ ನಡುವೆ ಏನು electrostatic force should be present because it's a positive charge, it's a negative charge. Okay, negative ಮತ್ತೆ positive charge ಇದ್ರೆ usually electrostatic forces are there. Electron will experience the force of attraction, that is an electrostatic force present in that. And this model, it looks like a what? Watermelon. Okay, so just see that that's why I am shaded with a red color for the positive charge species and dark color, black color for the seeds. Okay, just this model we can also called as an watermelon model or plum pudding. Plum in the sense what? Soft portion present in a watermelon, and pudding refers to seeds. Okay, pudding refers to seeds. Plum pudding model or watermelon model ಅಂತ ಕೂಡ ಕರೀತಾರೆ. Or one more is the resin modeling. Okay, resin modeling ಅಂತ ಕೂಡ ಕರೀತಾರೆ. There are three names are there to explain the J.J. Thomson atomic structure. Okay, according to him, you should remember these are plums. Okay, plums are positively charged species, seeds are the negatively charged species. Let us see some characteristic features of that J.J. Thomson atomic model. The first point is positively charged species is found regions present here. Okay, ಅಲ್ಲಿ ಏನು red color region ಇದೆ, that are positively charged species. Okay, that are bonds, and the seeds are electrons. And masses are uniformly distributed. This is a very important point regarding the J.J. Thomson atomic model. Masses of an atom which is equally distributed, uniformly distributed. Okay, entire region consists the mass of an atom. Okay, next further experiment ಮಾಡಿದಾಗ that is failed, but according to J.J. Thomson model, which is a major point in that, what is that? Mass of an atom is uniformly distributed in an atom. ಒಂದು atom ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ entire mass should be uniformly distributed, ಎಲ್ಲವೂ ಕಡೆ ಕೂಡ ಇದೆ ಅಂತ ಇಂಡಿಕೇಟ್ ಮಾಡ್ತಿದೆ. And there is one drawback is present. Okay, so many drawbacks are there, but ಅದರಲ್ಲಿ ನಾವು ಒಂದು ಪಿಕ್ ಮಾಡುವಂತದ್ದು ಏನು drawback? He can explain only the neutrality of an atom. Okay, ಬೇರೆ ಯಾವುದನ್ನು ಕೂಡ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಲಿಕ್ಕೆ ಆಗಲಿಲ್ಲ. ಓಕೆ, ಇವನಿಗೆ ಆಗಿದ್ದು ಯಾವುದು? explain only the neutrality means what? The positive and negative charge species. Okay, seeds and plums are equally distributed in a watermelon model, so that should be balanced by positive and negative, and should be the balanced each other. Positive charge and negative charge are balanced each other. That's why this is taken as drawback. So he explained only regarding, or ಇದನ್ನ ನೀವು characteristic features ಆಗಿ ಕೂಡ ತಗೋಬಹುದು. He can explain the neutrality of an atom. Okay, drawback ಗೆ ಬಂದ್ರೆ he can explain only the neutrality of an atom. This is regarding the J.J. Thomson atomic model. Next class we will continue with the one more atomic model is there. That's the Rutherford alpha ray scattering model that we'll discuss in the next class. Thank you.